right, so let's look at the first homework problem from section 3.6. This is a non-homogeneous differential equation, and they have asked us to solve it using variation of parameters. Now, you should immediately recognize here that I could do this with undetermined coefficients. And I think that it's always good to tackle something as complicated as variation of parameters with something that you know what the solution should end up looking like. And in fact, let's solve this really quickly with undetermined coefficients. If these have constant, this is a differential equation with constant coefficients. So my characteristic polynomial would be r squared minus 5r plus 6 is equal to 0. And that does factor to r minus 3 times r minus 2 is equal to 0, which means that the complementary solution would be c1 times e to the 3t plus c2 times e to the 2t. And then when I went to go and find the particular solution, I would say that since this is e to the t, and that is going to be linearly independent from both of my complementary solutions, that it would look something like a times e to the t. Now, I could go to Mathematica here, but I think it's, since the derivatives are just going to keep being e to the t, hopefully I don't need to go to Mathematica in order to ask it that. And so then if I plugged it into the original equation, I have y double prime minus 5y prime plus 6y. I would have a e to the t minus 5 times a e to the t plus 6 times a e to the t, and I would need that to be equal to 2 e to the t, and it looks like I have 2 a e to the t to be equal to 2 e to the t, so a is equal to 1, which would mean that my solution is c1 e to the 3t plus c2 e to the 2t plus the particular solution, which is e to the t. All right, if this problem ends up on the exam, that's absolutely the way that you should solve it. We're going to try to do this with variation of parameters, which is going to be a much harder way of solving this question, but it's hopefully going to give us some insight to variation of parameters. So let me get a little space here. And let's rewrite the question again. So y double prime minus 5y prime plus 6y is equal to 2 e to the t. My first step is exactly the same. I want to find the solution to the complementary equation. So y double prime minus 5y prime plus 6y is equal to 0. We did the work above, so the complementary solution is c1e. I want to make sure that I order it in the same way. I put the 3 before the 2, so 3t plus c2e to the 2t. So there is my complementary solution. Next, I want to get into variation of parameters. Now, in the last video, we did a lot of derivation and everything, and now we are just focused on the computation. The first thing that I want to do is to find the Wronskian of the complementary solutions. So e to the 3t, e to the 2t. The derivative will be 3e to the 3t, 2e to the 2t. I want the determinant of that. Multiply in this direction. I will get 2 times e to the 3t times e to the 2t is e to the 5t. And then minus what I would get in this direction. That's going to be 3 times e to the 5t. So the Wronskian is negative e to the 5t. Then I want to find the Wronskian, the w sub u1 prime. The second column is going to stay the same, e to the 2t, 2e to the 2t. And you'll recall that when we were solving that system of equations, what that back in the first video, what we always got was that it was equal to, the first equation was equal to 0, and the second equation was equal to the f of x, or f of t. That's this. So at this point, you will always put a 0. That will always be a 0. And then in the second row is always going to be the thing that made the differential equation not homogeneous. So 2e to the t, right? 2e to the t. Multiply this way, multiply this way. I get 0, and then minus 2e to the t times e to the 2t. That'd be minus 2e to the 3t. Similarly, y sub u2 prime will be the first column, which was e to the 3t, and then 3e to the 3t, and 0 to e to the t. It's always going to be 0 and that thing that made it not homogeneous. Multiply in this direction, I will get 2e to the 4t minus 0. All right, what comes next? I will get that u1 prime is equal to the w sub u1 prime divided by w. And then u2 prime is going to be similar. So I get that u1 prime will be the negative 2e to the 3t divided by the Wronskian of the homogeneous solutions, negative e to the 5t. So negative e to the 5t. And I'm just wanting to make sure that I did that right. And then u2 prime is going to be equal to 2e to the 4t divided by the same negative e to the 5t. Both of these are going to simplify. This one will be 2e to the negative 2t. The second one will be negative 2e to the negative t. I believe I've got that correct. Yes. These are u1 prime. So I will find u1 by integrating 2e to the negative 2t dt, which will be 2e to the negative 2t divided by negative 2 plus c, which will get me a negative e to the negative 2t plus c. I'm going to leave the plus c there because I need to justify to you why I can not write it. So I'm going to write it there, and we'll see what happens. And then similarly, u2 prime, or u2, will be equal to the integral of negative 2e to the negative t dt, which is going to be negative 2e to the negative t divided by negative 1 plus c. So I will get 2e to the negative t plus c. All right, let's just pause and make sure that we're clear about where we were. If I go back up to the top, took the differential equation, solved the homogeneous part, got the two y1 and y2, e to the 3t, e to the 2t. Found the Wronskian of those solutions, substituted in 0 f of t for the first column, found the determinant, substituted in 0 f of t for the second column, found the determinant, found u1 prime and u2 prime, and then integrated to find u1 and u2. Recall that the form of the solution is that y is equal to c1y1 plus c2y2, the complementary solutions, plus u1 times y1 plus u2 times y2. So for us, I get c1 e to the 3t plus c2 e to the 2t plus u1. What was u1? u1 was negative e to the negative 2t plus c. Negative e to the negative 2t plus c times y1, which is e to the 3t, plus u2, which is right here, 2e to the negative t plus c times u2, which is e to the 2t. Now, if I start simplifying things out, what I want everybody to recognize is that right here is c e to the 3t, and here is c e to the 2t. Those are going to get combined with the part from my complementary solution. So whatever those constants ended up being, I would put those together with the constants in the beginning. So I don't need this. That's why I don't have to do plus c on that integral. The rest of it I do need to do. So I've got the same c1 e to the 3t plus c2 e to the 2t. If I multiply this in, that will be minus e to the t, right? So I got minus e to the negative 2t, e to the 3t, so that's going to be e to the positive t. And then the other one will be plus 2e to the t, which is going to simplify to exactly what I got before. c1 e to the 3t plus c2 e to the 2t plus e to the t. And just to point that out, I want you to recognize that if I scroll all the way back up here, that is exactly what we got when we did it with undetermined coefficients. Clearly, this problem should be done with undetermined coefficients, but since variation of parameters is this new and very complicated thing, it's worth going through this example to see that it does get us to the exact same place. If this problem ends up on the exam, please do it by undetermined coefficients and not by variation of parameters.